All right, section 11.2 is going to focus on ways of expressing concentrations of solutions. Now remember, concentration is just an expression of how much solute is dissolved in your solvent. Now, excuse me, last year we talked about two ways to express concentrations through molarity and molality. And we're going to continue to express in those ways. However, there are a few other ways in which chemists can express concentration. And what we're going to do is I'm simply going to give you the equation, and then once I give you the equation, we're going to go through a few of these practice examples in class, because if we sat and went through a practice example for each equation, the video would be 40 minutes long. So what we're going to do is we're going to sit here, we're going to go through the equations, write down the equations. Your quiz will be based off molarity and molality, since you already know how to do those, and then we'll talk about the other types of equations in class. So mass percentage. Mass percentage. Now we did percent composition last year, which is similar, but mass percentage. What is mass percentage? It's, well, when you're figuring out the percentage, you're going to take the part over the whole. So if you're figuring out the mass percent of A, you're going to take the mass of A divided by the total mass of the solution, which is the percent composition. So we did do this one last year. So mass percentage is one way which we can figure out the concentration of a solution. What we're really going to do is when you use this mass percentage, you're going to use this mass percentage to calculate in two units in which chemists use quite a bit, particularly when we're talking about small concentrations. And when we talk about small concentrations, we use parts per million and parts per billion, ppm and ppb. So if you're going to figure out parts per million, you're going to do the mass percentage like we just did, the mass of A divided by the total mass of the solution, and multiply it by 10 to the 6th, which is a million. Or if you're going to do that for parts per billion, instead of doing it times 10 to the 6th, you're going to do it times 10 to the 9th, which is for a billion. Now these two are particularly used in industry. You have an allowable amount of chemicals in the parts per million and parts per billion in your air, in your water, in everything that's made, even in candy. Like there can be toxins in the parts per billions in food. Just as long as it's under a particular amount, it is still safe to eat. So parts per million, parts per billion, two types of concentrations that are used. Mole fractions. If we figure out a mole fraction, instead of taking the weight in grams, now we're going to take the moles of the entire solution. So we're going to take our moles of A divided by our total moles of solution, and that will get us our mole fraction. Now sometimes it's going to ask you for the mole fraction of the solvent, not the solution, just the solvent. So you need to make sure we're solving for the correct application. I just point that out, and I will reiterate that in class again tomorrow. And then here's our two standbys that we talked about last year. Molarity. Molarity is equal to moles of solute divided by liters of solution. So it's moles over liters. That's a very simple calculation. We worked in molarity all last year. We focused on it last year as well. You guys are very in tune with molarity. Now remember, molarity can change with temperature, because the higher the temperature, the more substance that you can dissolve in a solution. So something to keep in mind there as we review 13.1 quick. And lastly, we have molality. Now molality is moles of solute divided by kilograms of solvent. So remember, the difference is molarity is liters of solution. Molality is kilograms of solvent. So something to keep in mind there when we talk about molality. Since both moles and mass do not change with temperature, molality is not temperature dependent. So something to kind of keep in mind there. So molarity is, molality isn't. Remember, we use most of the time in molarity. Now, if you need to go from molarity to molality, you can solve that doing that using the density of the solution. And if you figure out the density of the solution, you can figure out the weight of the solvent. And if you know the weight of the solvent, you can figure out kilograms of solvent and therefore solve for molality and molarity. We will do an example of that tomorrow in class. Essentially, your quiz is going to be a review of your molarity and molality basics, and then we are going to convert between the two in class tomorrow and review parts per billion and parts per million. So, different ways we can measure concentration in the world of chemistry. All of them are great ways to measure concentration. So again, parts per million, parts per billion, mole fractions, percents, and then molarity and molality, all ways that we can measure concentration in the world of chemistry.